The burgeoning short video industry has led to significant advancements in video music retrieval technology, facilitating content creators in selecting suitable music for their videos. However, self-supervised training for video-to-music retrieval often suffers from noisy data, where video and music samples from the same video work are separated, resulting in one-tune matches that do not accurately reflect real-world scenarios. In reality, a video can use different music as background music, and a music can be used as background music for different videos, leading to false negative noise in the dataset. To address this challenge, a novel Inter-Intra Modal loss is proposed, which reduces the variation of feature distribution within the two modalities before and after the encoder. By minimizing the drastic changes in feature distribution within each modality, the loss effectively mitigates overfitting on noisy data, allowing for more accurate retrieval of relevant matches without requiring complex noise removal techniques. The proposed framework, Inter-Intra Contrastive Learning for Video Music Retrieval, IICLVM, incorporates the loss and achieves state-of-the-art performance on the YouTube 8M dataset. The framework also employs global sparse (GS) sampling, enabling music retrieval to be based on the content of the complete video, rather than on fixed-duration video clips. Additionally, the framework can easily integrate multimodal video information, such as images and text, to achieve better performance. The contributions of this paper include the proposal of Inter-Intra Modal loss, loss, which enables retrieval models trained on noisy data to have better generalization ability. The IICLVM video music retrieval framework is also developed, which incorporates loss and achieves state-of-the-art performance on the YouTube 8M dataset. The paper also reviews related work on contrastive learning and cross-modal retrieval, highlighting the use of pre-trained features and contrastive learning to learn rich matching rules in large-scale video music datasets. The authors note that retrieving a music for a video is usually treated as a cross-modal retrieval task, and that contrastive learning enables the model to learn various video music matching factors in a self-supervised training way. The cosine distance of the encoded cross-modal features is used to assess the suitability of media candidates. However, the cross-modal training objective is to minimize the distance between positive samples and maximize the distance between negative samples. When the model is overfitted to the noise, the distance between many false negative sample pairs is maximized, leading to a decrease in the model's generalization ability. The loss addresses this issue by using the intra-loss component to minimize drastic variations in the feature distributions within each modality during training. This approach effectively mitigates overfitting on noisy data and allows for more accurate retrieval of relevant matches without requiring complex noise removal techniques. The paper's experiments are designed to show that loss can effectively alleviate the problem of false negative noise in retrieval tasks. The results demonstrate that loss improves various self-supervised and supervised unimodal and cross-modal retrieval tasks, and can obtain good retrieval models with a small amount of training samples. The Inter-Intra Contrastive Learning for Video Music Retrieval, IICLVM, model introduces a novel Inter-Intra Modal loss function to facilitate contrastive learning for video music retrieval tasks. The model's architecture, depicted in Figure 1, applies the global sparse sampling method to extract pre-trained feature sequences from videos and music. These features are then encoded using video and music encoders, and the intermodal similarity matrix S, as well as intramodal similarity matrices SV, SM, and SM, are calculated. The intermodal loss is computed from the matrix S, while intramodal losses for video and music modalities are calculated using SV, SM, and SM, respectively. This approach enables the model to capture both intermodal and intramodal relationships between video and music features. Existing works on cross-modal retrieval tasks, including binary classification, ranking, triplet loss, and canonical correlation analysis, CCA, are reviewed. Recent methods, such as CLIP and its extensions, have demonstrated the effectiveness of contrastive learning for cross-modal retrieval tasks. However, these methods often rely on simple cross-entropy loss functions or triplet loss, which may not fully capture the complexities of cross-modal relationships. In contrast, the IICLVM model integrates both intermodal and intramodal losses to prevent intramodal structure collapse during cross-modal training. This approach is similar to recent works that have explored different pre-training methods, such as BLIP, which enables encoders to migrate well to caption and QA tasks. The importance of selecting an appropriate background music, BGM, for videos based on their contents is also discussed. Early works relied on matching labels, while recent algorithms have employed self-supervised contrastive learning methods to learn rich factors and patterns. The IICLVM model's ability to capture both intermodal and intramodal relationships makes it a promising approach for video music retrieval tasks. The IICLVM framework is designed for video music retrieval tasks, comprising global sparse sampling, sequence encoders, and an inter-intra modal loss. During training, N video music pairs are fed into the model in each mini-batch. Global sparse sampling extracts feature sequences from both video and music, which are then fed into separate sequence encoders to obtain video and music embeddings. The inter-intra modal loss is a novel component that measures the distance between the encoded video and music embeddings. It consists of two components: intermodal loss and intramodal loss. The intermodal loss is calculated based on the cosine similarity matrix S, where each element is the cosine similarity between video and music embeddings. This loss is defined as the cross-entropy loss between the similarity matrix and the identity matrix, with learnable temperature parameters and adjustable weights. The intramodal loss preserves the relative feature distribution of the music samples in the encoder output, preventing the distance between false negative sample pairs from increasing. The overall loss function is a weighted sum of the intermodal loss and the intramodal loss. This approach addresses the limitation of existing video music retrieval methods, which consider only one continuous fixed duration clip from the original media, ignoring the rest of the video and music. In contrast, IICLVM's global sparse sampling extracts features from the entire video and music, enabling content-based retrieval rather than duration-based. The sequence encoders, such as BILSTM or transformer encoders, extract temporal information from the frame-level video and music feature sequences. The encoded video and music features are then used to compute the inter-intra modal loss, allowing the model to capture nuanced relationships between video and music. The development of a novel framework for cross-modal retrieval, specifically video music retrieval tasks, is presented in this research paper. The proposed inter-intra contrastive learning for video and text-to-music retrieval, IICLVTM, model leverages both video and text features to enhance the retrieval process. By incorporating text information, such as video descriptions or titles, alongside video features, the IICLVTM model aims to improve the accuracy of background music selection for videos. A BILSTM encoder is employed to fuse and encode raw video features and text feature vectors, enabling the model to capture complex relationships between video and text modalities. Experimental evaluations on the YouTube 8M dataset, comprising 149,213 video samples labeled as music video, demonstrate the effectiveness of the IICLVTM model in video music retrieval tasks. Notably, the model alleviates the problem of false negative noise in retrieval datasets. The calculation of intramodal loss for the video modality involves computing two intramodal similarity matrices before and after encoding. Intermodal similarity matrices are also computed, and the total intramodal loss is calculated. This comprehensive approach enables the IICLVTM model to capture nuanced relationships between video and text features, leading to improved performance in cross-modal retrieval tasks. A novel approach to video-to-music retrieval is presented, focusing on the development of an inter-intra modal loss, to enhance cross-modal retrieval tasks. The proposed framework, IICLVM, integrates the to-loss with a cross-modal variational autoencoder, CLVM, and a sequential encoder. This framework is designed to capture both intermodal and intermodal relationships between video and music, improving retrieval performance. The authors evaluate the effectiveness of the to-loss by testing different sampling methods, encoders, and retrieval tasks. Results show that the global sparse (GS) sampling method significantly outperforms the fixed duration (FD) method, with an increase in retrieval performance from 7.5% to 22.1%. Furthermore, sequential models such as self-attention and Bilsteum are found to outperform non-sequential models like FC and GCN, highlighting the importance of considering temporal information in cross-modal retrieval tasks. The IICLVM framework achieves state-of-the-art results in both video-to-music and music-to-video retrieval tasks, outperforming previous works. A subjective evaluation is also conducted to assess the quality of retrieved music for videos. Results indicate that the proposed model Bilsteum, IICLVM, performs well, with 57.27% and 82.07% of participants preferring the retrieved music over random selections and original music, respectively. This suggests that the retrieved music generally matches the video content better than the original music. The proposed approach demonstrates the effectiveness of the two-loss and the IICLVM framework in enhancing retrieval performance. The results provide insights into the importance of considering temporal information and modalities in cross-modal retrieval tasks, highlighting the potential of this approach for various applications. The authors evaluate the performance of their proposed Inter-Intra Contrastive Learning (IICL) framework for text-to-music retrieval on the YouTube 8M music videos dataset. The results, presented in Table IV, demonstrate that using video and text together for music retrieval achieves higher values than using video or text alone, regardless of whether the text information is the title or the keyword. This suggests that multimodal features are essential for effective music retrieval. The authors also assess the generality of the two-loss function on different cross-modal retrieval tasks, including audio text, image text, and video text retrieval. The results, shown in tables V, 7, and 8, indicate that the two-loss function improves performance on all datasets, including Clotho, MSCOCO, Flickr 30K, MSVD, MSRVTT, and VATEX. Furthermore, the two-loss function is compatible with different pre-trained features, such as VGGISH, PANNs, VITB, 32, ClipVIT, and Blip. Figure 5 illustrates the inter-loss and intra-loss during training, as well as the values during testing as a function of the epoch number. The results demonstrate the effectiveness of the two-loss function in improving model performance on cross-modal retrieval tasks. The inter-loss measures the difference between the predicted and actual matching scores, while the intra-loss measures the difference between the predicted and actual non-matching scores. The proposed IICL framework is defined as the sum of the inter-loss and intra-loss, which is calculated using the metric that measures the recall at K. The experimental results demonstrate the effectiveness of the IICL framework for text-to-music retrieval and the generality of the two-loss function on different cross-modal retrieval tasks. The authors assume a basic understanding of deep learning, contrastive learning, and self-supervised learning, as well as familiarity with the concept of cross-modal retrieval and the different modalities involved. The experimental results demonstrate the effectiveness of the proposed Inter-Intra loss function in improving video text retrieval task performance. Tables 8 and figures 46 present the results on three datasets: MSVD, MSRVTT, and VATEX. The two-loss function consistently outperforms baseline methods, including ClipVIT, ClipText, VidSwin, and BlipImage, with improvements ranging from 3.5% to 10.5%. The two-loss function achieves the highest scores on all three datasets, showcasing its robustness. Figure 4 illustrates the impact of increasing the intra-loss weight gamma-2 on downstream tasks, particularly those with smaller data volumes. For instance, on the Clotho dataset, the values increase from 9.62 to 14.09 as gamma-2 increases from 0 to 10. This highlights the two-loss function's ability to adapt to varying data volumes. Figure 5 compares the two-loss function's performance with a baseline method using only inter-loss. The results indicate that the two-loss function prevents inter-loss from overfitting to the noisy training set, achieving lower intra-loss and higher testing set scores. Figure 6 examines the two-loss function's effectiveness in resisting false negative noise interference, demonstrating its ability to mitigate adverse effects and achieve the highest value with a batch size of 128. The experimental results demonstrate the two loss functions' effectiveness in improving video text retrieval task performance and resisting false negative noise interference. The two loss function prevents inter-loss from overfitting and achieves higher testing set scores. Its impact is more pronounced on downstream tasks with smaller data volumes. Two experiments on the YouTube 8M and Caltech 256 datasets further validate the two loss function's ability to resist different levels of noise interference in training. Overall, the two loss function is a valuable tool for improving video text retrieval task performance, particularly in scenarios with limited data. The training inter-loss, intra-loss, and testing curves in Figure 5 demonstrate the effectiveness of the two loss in mitigating the impact of increased noise in the training data. When training with inter-loss only, the curves exhibit significant variation over epochs. In contrast, training with two loss yields more stable curves, indicating improved robustness to noise. Figure 6 illustrates the relationship between batch size and the variation of the CLVM model's performance on the YouTube 8M dataset. As batch size increases, the performance of CLVM decreases due to increased noise. However, the intra-loss in IICLVM reduces the influence of noise, significantly slowing down the reduction in performance. The Caltech 256 dataset is employed for image retrieval tasks, with the recall at 1 metric used to measure retrieval performance. The experimental setup involves randomly selecting positive sample pairs from the same category and simulating different levels of noise by arranging multiple pairs of samples from the same category in each training batch. 4 experiments are conducted: no noise, with noise, more noise, and most noise, with increasing amounts of noise. The results, presented in Figure 7, demonstrate that two loss has little effect on recall at 1 in the no-noise group but shows significant improvement compared to the non-II loss group as the noise increases. This highlights the effectiveness of two loss in enhancing the model's generalization ability in the presence of noisy data. The IICLVM framework maintains pre-trained feature distribution within the two modalities during training on noisy cross-modal datasets, improving the model's generalization capabilities. The IICLVM framework has achieved state-of-the-art results on the YouTube 8M dataset for video music retrieval tasks. Furthermore, the two loss has been found to be valuable for other cross-modal retrieval tasks, enabling the development of good retrieval models with a small number of training samples. The results emphasize the importance of the two loss as a key innovation in the IICLVM framework. The figure, Fig. 7, from the research paper illustrates the relationship between the increment of with or without two loss and the noise level in the batch on the Caltech 256 dataset. The stacked bar chart demonstrates that as the noise level in the batch increases, the without two loss drops rapidly. In contrast, the effect of two loss on improving is significant when the noise level is high, particularly in areas such as retrieval performance on tasks involving large datasets and the development of noise-resistant methods for end-to-end retrieval models. The authors highlight the potential of two loss to become an even more effective and versatile tool in the field of cross-modal retrieval by addressing the challenges of large datasets and noise resistance. The paper concludes by citing various challenges and opportunities for future research in this area. In the realm of computer vision and natural language processing, various deep learning models and datasets have been employed to tackle complex tasks. The Inception architecture, a seminal work in image recognition, has undergone refinements to enhance performance. Moreover, transformers have been successfully applied to image recognition at scale, demonstrating their efficacy. Models designed for action recognition in videos, such as those proposed by Wang et al. And Carrera et al., have also shown promising results. In the audio domain, the AudioSet ontology and human-labeled dataset have facilitated the recognition of audio events. The PANN's model has been instrumental in audio pattern recognition, achieving state-of-the-art results. Temporal segment networks have been employed for deep action recognition, while the YouTube 8M dataset has been utilized for video classification. The paper also surveys datasets for image and video captioning, including Clotho, Microsoft Coco Captions, Flickr 30K entities, and MSRVTT. Additionally, datasets for paraphrase evaluation, such as the ones proposed by Bagot et al., and multilingual video and language research, like the one introduced by Chen et al., are discussed. These datasets have been instrumental in advancing research in their respective areas, enabling the development of more sophisticated models and algorithms.